Hello friends, in today's question, the amplitude of a damped oscillator decreases to zero point 0.9 times its original magnitude in 5 seconds. In another 10 seconds, it will decrease to a, there should be alpha times its original magnitude, where alpha is equal to, so we are supposed to find out value of alpha when the total time elapsed in case of the damped oscillator is 15 seconds. In the first 5 seconds, it is given that it decreases by 0.9 times, and additionally we have to find out what will be the decrease in the 10 seconds. So the total time elapsed from the start to end is total 15 seconds. So we are going to start with the damping equation. We say that general damping equation can say that the amplitude of a damped harmonic oscillator it is given as A of t is equal to A naught e raised to power minus gamma t, and this is our gamma t. Normally in the equation of the, you can say for the damped harmonic oscillator, in place of the gamma, usually the notation that is used is alpha. But in the question, the alpha is being used for the amount of the decrease. So we are going to simply replace that particular notation by a gamma. And herein we can say that our A of t is the amplitude at time t, amplitude at time t. A naught is our initial amplitude, gamma is the damping constant, and t is the time. Now we are going to find out that in the first part, it is given in the question that in the first 5 seconds, the amplitude is reduced to 0.9 times the original value. So we can say at t is equal to 5 seconds, the amplitude decreases to 0.9 times the initial value times the original amplitude. Therefore, we can write that our A of 5, substituting value of t as 5, will be equal to 0.9 times A naught. And substituting this, let us call this as equation number 1. So using equation 1, from equation 1, we get 0.9 times A naught is equal to A naught e raised to power minus gamma multiplied by time, that is 5. Now we can just simplify it. A naught and A naught cancels out, and this gives us that e raised to power minus 5 gamma is equal to 0.9, and from here we can find out a value of gamma. We can say that gamma is approximately equal to 0.02108 per second. This is the approximate value of gamma. Now we are going to find out the value of alpha after 15 seconds. Okay. 5 seconds is the initial time and additional 10 seconds, so that will be total amount of 15 seconds from the initial state. Therefore, we can say that the value of alpha after 15 seconds, after 15 seconds. So once again, we are going to use equation number 1. So we can say, using from equation 1, we get amplitude at 15 seconds, A of 15 will be equal to our A naught e raised to power minus gamma multiplied by 15. And we already found out the value of gamma, so we substitute here. We get A of 15 is equal to A naught e raised to power, this is our minus, and 0.2108 multiplied by 15. So we can just write it as this will be equal to, we get this as, let us substitute, or we can say find out this value. So we can say by e raised to power minus 0.02108 multiplied by 15, and this will be approximately equal to 0.729. Therefore, we can say that our A of 15 will be equal to 0.729 multiplied by A naught. And in the question it is mentioned that it will decrease to a alpha times its original magnitude. The original magnitude is our A naught and alpha times. So this comes as alpha times. Therefore, we can say that if we equate this alpha into A naught, so making a comparison from here, we can say that our alpha is equal to 0.729. So the options that are available to us, if we check it, option number C is the correct option. We can say option C is correct. Option C is correct. So this completes the question. Thank you.